Perfectly honest, it actually is because it's less work, it's less steps. All right. So we're on page 9 of your packet. So it should say solving fractional equations up top. So technically, this is lesson 4.5. We're skipping 4.4 because that's word problems. We'll do that tomorrow. All right. So 4.5 is in two parts. There are two types of rational equations. There are proportional ones and non-proportional ones. So when I say proportional, what does that sound like to you? So when you hear the word proportional, well, they're all equal because they're equations. But what does it mean for something to be proportional to it? Fractions. So in other words, fraction on one side, fraction on the other. So today we're going to look at the proportional ones. Later on this week, we'll look at the non-proportional ones. Both are not necessarily hard to do. They just have different processes. All right. So first thing we're going to do is, and Kylie, can you hit the light? It's really light. So equations involving fractions or rational expressions arise frequently in mathematics. And the key to working with them is to manipulate the equation, typically by multiplying both sides of it by some quantity that eliminates the fraction. Or the most common form is cross multiplying. All right. So you guys should be very familiar with cross multiplying. That's usually your answer to everything when I ask you guys to multiply fractions. It's cross multiplying. All right. Now you actually get to do it. So let's look at exercise 1, part A. So proportional rational equations. If the equation is proportional, so if it's proportional, that means there is one fraction on each side of the equal sign. If there's more than one, or if there's like a 1 plus a fraction, it's not proportional. So we can only use this method if it's proportional. So letter A is clearly proportional because we have one fraction on this side, one fraction on this side. There's nothing being added or subtracted to that fraction on either side. So we can go right into cross multiplying. So remember, cross multiplying means you multiply directly diagonal to the two fractions. And we're going to write these expressions with multiplication. So that means we're going to have 5 times 4x plus 5 is equal to 2 times x minus 1. And just like that, we took that rational expression and turned it into a linear equation. And now we can solve. What's my first step for solving? Distribute. So I'm going to distribute on both sides. 5 times 4x is 20x. 5 times 5 is 25. Is equal to 2 times x is 2x. 2 times negative 1 is negative 2. What's my next step? Right, we want to get the 2x on, or the x is on one side, so I'm going to subtract 2x to both sides. It didn't really matter which x we moved. I typically move the smaller one, so I have positive coefficients in front of the x. So this would be 18x plus 25 is equal to negative 2. What's my next step? So, what's my next step from here? Now I just got 2 steps. Minus 25 to both sides. That goes away. I get 18x is equal to negative 27. What's my last step? Divide by 18. Now, this would not give us a nice whole number, but we can simplify that fraction. What does that fraction simplify down to? Not, yes, it is 3 over 2. We can divide both the top and the bottom by 9 over 9. So this would be negative 3 over 2. So x is equal to negative 3 halves. So that's our answer for this one. So like I said, it looked like an ugly problem, but it actually wasn't too bad. Because by cross multiplication, we turned that ugly problem into something a bit more manageable. All right, any questions on that one? So this was a linear proportion because it turned into a linear equation. Now let's look at one that's not linear. So look at this one. So we're going to do the same thing over again. We have a fraction on each side. There's nothing being added or subtracted to it. There's not another fraction on either side. So we're going to go ahead, start cross multiplying. So how would I set this up if I cross multiply? What would the green set up to be? X minus 6 times x plus 1 is equal to, what's the red turn out to be? 2 times 2 minus x. So I just set up my equation. Now, judging from what this equation looked like, what type of equation do you think this is going to be? It's not going to be linear, but it's going to be another type of equation you should be fairly familiar with. It'll be quadratic. All right. So we're going to go ahead and distribute these two factors. How do I handle the x minus 6 times x plus 1? What do I need to do? A box. So for this one, I'm going to do a quick box method. So x minus 6, x plus 1. This will be x squared minus 6x plus x minus 6. Combine the like terms. I get x squared. What's negative 6x plus 1x? Negative 5x minus 6 is equal to, what do I need to do to the right side? Distribute. So I got 4 minus 2x. Now, when you solve any quadratic, whether you do it by factoring, quadratic formula, completing the square, taking a square root, whatever, what do you always have to get one side the equal sign to? 0. You got to get one side of the equal sign equal to 0. So my suggestion to you is move stuff from the side where the x squared is not, because you want that x squared value to be positive. So what do you want me to move first to the other side? Negative 2x. All right, how do I move it? We add 2x to both sides. What value on the left side am I adding that 2x to? Negative 5x. That goes away. I'm left with x squared minus 3x minus 6 is equal to 4. Still don't have one side equal to 0, so what do I have to do next? Subtract the 4 to both sides, and where does the 4 subtract to? The negative 6. Remember, it's like combining like terms. So that goes away. X squared minus 3x minus 10 is equal to 0. Now, from here, there are two ways to go about this. All right. The easiest way is to check to make sure to see if that quadratic factors. Because if it factors, it's really straightforward. If it doesn't factor, you got to use quadratic formula. So just to note so that you have it, the quadratic formula is this. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's when you're given a of x squared plus bx plus c is equal to 0. So that's the quadratic formula when you're given the standard form of a quadratic equal to 0. And remember, with quadratic formula, you only use the coefficients in the quadratic formula. Do not throw any x's in there. Now, looking back at this quadratic, so this one right here, we're going to test to see if it's factorable. So remember, we're going to do big X, see if we can find some factors that will add up to the number that we need to. If we can't, we use quadratic formula. When in doubt, quadratic formula always works. All right? It may be a little bit more work than factoring, but if you absolutely do not trust yourself with the factors, get used to using quadratic formula. Because again, quadratic formula works for any quadratic. Factoring only works for factorable ones. So if we're going to try by factoring, I'm going to do big X. What goes on top of big X? A times C, which in this case is negative 10. Because A is 1, C is negative 10. 1 times negative 10 is negative 10. What goes on the bottom? Negative 3, my B value. So if I'm multiplying to negative 10 and adding to 3, I need two numbers that multiply to negative 10, add to 3. Since I'm multiplying to a negative number, that means that one of those factors has to be what? Negative. So let's list some factors of negative 10, or just 10 in this case. What are some factors of 10? 1 and 10, 2 and 5. Which one could potentially add to negative 3 if it was negative? Right, negative 5 and positive 2. So this would be negative 5. This would be positive 2. And then since I have these two factors and my A value is 1, I can just write out my factors as x minus 5 times x plus 2 is equal to 0. And the only reason I can do that is because my A value of my original quadratic is 1. Now, how do I finish it up? You said both of them equal to 0, solve the two mini equations. So x minus 5 is equal to 0, x plus 2 is equal to 0. So if I do a quick solve, x is equal to 5, x is equal to negative 2. Now, before I say that those two are my solutions, I need to check to make sure they're not what we call extraneous. Extraneous means that it's a solution that we get when we solve, but it doesn't actually work when we plug it back into the equation. All right? Or it makes the equation undefined. When it comes to fractions, what would make a fraction undefined? Not an improper fraction, but think way, way back to when late elementary school, early middle school. Your teachers always told you that you cannot have a fraction with a certain denominator. What number would that denominator be? 0. So, an extraneous solution. Extraneous means if you plug it back in for x, in the original equation, it makes a denominator equal to 0. All right. And we know that no denominator can be 0. So in reality, we just got to plug those two values in for x into the denominators. So just a quick plug in. 2 minus 5, that's negative 3, so that's fine. 5 minus 6 is negative 1, that works. Negative 2. 2 times 2 minus negative 2, that negative 2 turns to a plus, so 2 plus 2 is 4. Negative 2 minus 6 is negative 8, so both work. So your answer is x is equal to the set of -2 and 5. So if there are x's in any of your denominators, take a minute and plug those solutions back in for x in both denominators or wherever there's an x in the denominators, and make sure that they don't equal 0 when you evaluate the denominators. Because if they do, it's an extraneous solution and it's not included in your solution set. All right? So just be careful about that. They may throw one of those your way. Any questions on that one? All right, let's look at some more. So the far less familiar method is what we call the LCD method, or when you have 2 or more fractions involved on one side. So we're going to do more of these like later on next week, but not next week, later on this week, like more advanced ones, but we can at the very least do some simple ones. All right. So the simple ones are similar to, do you guys remember last week when we did complex fractions and we were trying to eliminate the denominators of the little fractions? It's very, very similar to that. All right. So if we're looking at this one right here, all right, I just want to look at the denominators specifically. So if I'm just looking at these denominators, so the 2, whoa, that doesn't work. So the 2, the 4x, and the 4x. Yeah, it looks nice on mine, not so much on theirs. So I'm only looking at those 2 denominators. Least common denominator, all right? That means that if I had a number, it would be easily divisible by 2 and 4x, all right? So in other words, it's a number that can be divided by your denominators evenly. And you want the smallest version of it because there's obviously multiple numbers where that would work. So we call that LCD. So let's think about this. 4x and 2, they can both be divisible by what number? 2. All right, so they can be divisible by 2. However, can 2 be divisible by 4x? No. Could I multiply something to 2 to give me 4x? Yes. So, in other words, if you can manipulate the fraction to make it so that the denominator is that number, then that works. When in doubt, multiply the 2 denominators together. So a common denominator would be 8x if I did 2 times 4x, but the least common denominator in this case is 4x. Because I could change this 2 if I multiplied 2x to it to give me 4x, and these I could just multiply 1 to. So in other words, you're looking for a denominator that if you multiplied another number or value to it, you could get that denominator. All right. Now, we then multiply both sides of this equation by the LCD to clear the equation of the denominators. So like I said last week with complex fractions, the goal is to get the denominator to divide out. All right. So we're making the numerators bigger so that the denominators go away. So I'm going to rewrite this equation. So 1/2 minus 9 over 4x equals 3 over 4x. And I'm going to multiply the entirety of this equation by my LCM or LCD, which is 4x over 1. So all of my denominators will still be there. So the 2, the 4x, and the 4x. But now I'm going to multiply my numerators by 4x. So what's 4x times 1? 4x. What's 4x times 9? 36x. What's 4x times 3? 12x. Now I got some fractions that will simplify to give us whole values. Because what's 4x divided by 2? 2x. What's 36x divided by 4x? 9. The x's cancel. 36 divided by 4 is 9. So minus 9 is equal to 12x divided by 4x. 3. The x's cancel out. 12 divided by 4 is 3. And that's my new equation right there. The 2x minus 9 equals 3. And what does that look like to you? Looks like a nice two-step equation, right? So now that's very easy to solve. What's my first step? Add the 9 to it. So I get 2x is equal to 12. I'm just going to rewrite it over here. 2x is equal to 12. Then what do I do? Divide by 2. So x is equal to 6. And then if I do a quick check in my original, 4 times 6 is 24, so we don't have to worry about zeros. So it is our actual solution. So the hardest part of these is just finding the LCD. Yes. Yeah. Any questions on that one? All right, let's do another example. Yes. All right, so first off, which method do you think would be the most beneficial to use, the LCD method or the proportional method? So let me ask you guys this. Remember, proportional can only be used if there's only one fraction on each side and there's nothing else being added or subtracted to it outside of that fraction. How many fractions are going on here? There's 3. So that means the only method we can use is LCD. So proportional means you have one fraction equals another fraction and that's it. You have nothing else added or subtracted on the other side. Because there's 2 fractions over here on the left side, we cannot use proportional method. All right. So we're going to use LCD for this. So first things first, I need to find the LCD of these 3 denominators. So let's think about this. Can any of those numbers, if you divide it by another number, give you a nice number? No. However, can anyone think of a number that if we multiplied another number to any of those denominators, it would equal? Who said it? What's a number? 30 is one number. Can anyone think of another number? So there's multiple numbers that can work. 30 is one of them. What do you think would be another number? Multiply some of the numbers together. What do you get? 60 would work. What's another one? What's 10 times 15? 150. So those are some numbers that could work. So like I said, if you have a common denominator, it still works. Your numbers are just a little bit bigger and they still simplify down. But if you have a smaller number or the least common one, it's just less simplifying on your end. So in this case, the LCD is 30. So that's my LCD. So I'm going to take this equation. I'm just going to rewrite it. And I'm going to multiply everything by 30 over 1. So again, your denominators are going to stay where they are. So 6, 10 equals something over 15. Now I'm going to multiply 30 to all these expressions. Now, I'm going to write 30 times x minus 4 is a distribution problem, and you're not going to distribute it just yet. So I have 30 times x minus 4, 30 times x minus 2, and then can someone do 30 times 31 their calculator? I do not know that off the top. It's not 900, it's 930, I think. Yeah, it's 930. Now, the reason you don't want to simplify or distribute just yet is because you want to simplify these little fractions first. So 30 over 6, 30 over 10, and the 930 over 15. All right, if you distribute, it'll be harder for you to simplify. Remember, when you're simplifying, you can only simplify what type of relationships? Open relationships. What qualifies an open relationship in math? What operations? So what two operations? They're opposites of each other. What two operations qualify an open relationship where we can openly simplify? So is it adding, subtracting, multiplying, dividing? What do you think? Nope. Multiplication and division. Multiplication and division create open relationships. If something's being multiplied to another number and then divided by another number, it's fair game. What's the exclusive relationship? What can you not break apart? Parentheses or specifically, what's going on inside those parentheses? What operation? Addition and subtraction. So you can't break apart addition and subtraction. All right. So what's 30 divided by 6? 5. So I get 5 times x minus 4 plus, what's 30 divided by 10? 3 times x minus 2 is equal to, okay, so 930 divided by 15, that's 62. Correct me if I'm wrong. Awesome. 63. It doesn't simplify nicely? It should. 930 divided by 15? It's 62? Okay, that's what I thought. Equals 62. And now all the fractions are gone. We just have a linear equation. So from there, I distribute. Now I can distribute. This will be 5x minus 20 plus 3x minus 6 equals 62. Combine your like terms. So I'll combine my x's and my constants. This will be 8x minus 26 is equal to 62. Add 26 to both sides. That goes away. I get 8x is equal to 88. And then divide by 8. X is equal to 11. And that's my answer. And since all of my denominators are numbers, I don't have to worry about extraneous solutions. So your answer will be number 4. So guys, I'm flying through the actual solving, like the linear side, because you guys should be very familiar with doing that. If you're not and you need a recap, let me know. But at least with solving linear equations, I'm going to blow through that pretty quickly. Quadratic, I'll take some more time because I know that one you might not be as familiar with, which that's fine. All right, any questions on that example? All right, so we're going to stop there for today and come back to this later this week. So what we're going to do now is I'm going to give you guys a 5-minute break. So if you need to use the restroom, you may. If you want to chill for a second, you may. After that, there is a new Delta math for this. You only need to do the ones that say proportions on it. If you want to try like the first level of other rational equations, that's fine, but you really only have to